Alright, we're now doing 3.5, the identity section for the half angle, sine and cosine and tangent. So this is sine, half angle. Let's start off with the identity. Sine of x over 2 equals plus minus square root 1 minus cosine x inside over 2. Now, for our problem, we need to express 22/5 as some angle divided by 2. So if we double this angle, we get 45, which is a great angle to work with. So sine of 22.5 degrees is sine of 45 degrees divided by 2, giving us for our identity x, that'll go here and here, 45 degrees. So this will be plus or minus square root 1 minus cosine 45 degrees over 2. This is, we'll leave the plus minus to the end, although we could work it out any time. 1 minus square root 2 over 2 over 2. Now, this is kind of an awkward way to have it written. So what I'm going to do is I'm going to simplify this fraction bit by multiplying it by 2. But I can't just multiply it by 2. I have to multiply everything top and bottom by 2, giving me plus or minus square root 2 minus square root 2 over 4, which we can reduce the denominator as 2 because square root of 4, plus or minus still 2 minus square root 2. Now for the plus minus. Is it positive or is it negative? Well, 22.5 degrees is in quadrant 1, where all of the functions are positive. So our final answer is positive square root of 2 minus square root 2 all over 2. The key rewrites it a little bit different. Instead of all over 2 like this, they pull it out as a 1/2. That's okay. It's the same thing. Either way. All right, next question. Half angle formula. Well, before I do anything, I know that cosine is even. Cosine is even means that cosine of negative x equals cosine of x. So there's no reason why to work with cosine of negative pi eighths when we can work out. Because cosine is even, we can work with cosine of positive pi eighths. Now, to recognize this as a half angle, we have to think this is something divided by 2, and that is pi fourths divided by 2. Okay, now our identity that we're working with is cosine of x over 2 equals plus or minus the square root of 1 plus cosine x over 2. So our identity, we have x over 2, pi fourths over 2. So our x is pi fourths. So we're going to plug in pi fourths right there. So it'll be very similar to the last problem. We will have plus or minus square root 1 plus cosine of pi fourths all over 2. Let's take a quick look at the plus minus this time. So plus or minus, well, negative pi eighths is in quadrant 4. Cosine is positive in quadrant 4. So we're going to get the positive answer. If we deal with the odd and even and get this to be cosine of positive pi eighths, now it's in quadrant 1. Cosine's positive in quadrant 1 as well. So cosine's positive in quadrant 4 or quadrant 1. So either way, we end up that this is positive. Square root 1 plus square root 2 over 2 divided by 2, and I'm going to multiply by 2 in all three terms so that I can do that and get positive square root 2 plus square root 2 over 4, which you can then simplify the denominator, and you can also write that as a fraction 1/2 times square root 2 plus square root 2. Oh, that's good. Any of those answers would be perfect. All right, next question. Okay, half angle formula. If I write this as tangent of something halves, double my answer, the 7 pi eighths, and I get 7 pi fourths. This is nice because 7 pi fourths is a unit circle value. It's pi fourths in the fourth quadrant, where cosine is positive, tangent is negative. So our answer will be negative. But the tangent half angle formulas are slightly different. So we have two versions. Tangent of x halves can either be written as sine x over 1 plus cosine x, or 1 minus cosine x over sine x. It doesn't matter which one we use. Either one will give us the same result. So, knowing that x is 7 pi fourths, we're going to just plug in, I'll use the first one, we'll plug in 7 pi fourths in for the x's and get this is equal to sine 7 pi fourths divided by 1 plus cosine 7 pi fourths. Okay, again, pi fourth in quadrant 4. Sine is negative, square root of 2 over 2. Denominator 1. Cosine is positive, square root of 2 over 2. So in quadrant 4, all students take calculus. Cosine is positive. Sine would be negative, tangent would be negative. Only cosine is positive in this quadrant. All of them are positive here. Only sine here, only tangent here. Of the basic three, along with cosine, you would also have secant positive and cosecant and cotangent negative. Okay, continuing on. We have complex fractions here and here in a fraction, so I'm going to multiply again by 2 here and here and here so that I can do that. I have to multiply by 2 top and bottom everywhere, or else this is not a multiplication by 1 equivalent step. Let's see what we have now. We have minus square root 2 on the top. We have 2 plus square root 2 on the bottom. And this would be fine, except for most books want you to rationalize denominators, so we'd multiply by the conjugate and see what happens. So what happens on the top, we distribute, and we get minus 2 square root 2 plus 2. On the bottom, we have, foiling that out, we have 4 minus 2. Okay, so we have minus 2 square root 2 plus 2 over 2. And now we can divide everything by 2, just like we before multiplied everything by 2. To get this to simplify, I'm going to do this term first. That'll be 1. This is 1. Divide by 1 doesn't change. So we have 1 minus square root 2. All that's left. Alright. And again, why that's all that's left, these are the ones that cancel. So you have 1 and you have minus square root 2. Alright, that's it for that problem. At last, an easy one. What sine? Okay, all students take calculus. Quadrant 2. Sine is the only positive one in quadrant 2, so cosine is negative. That's your answer. Now you have to determine whether the positive or negative sign makes the equation correct, so negative. I like that. Next one. Alright, I see a couple of things here. First off, I see 2 cosine squared x minus 1. This is an identity. Now the identity that this reminds me of, the cosine double angle formulas. Let's see, cosine of 2x is cosine squared x minus sine squared x. Now if I convert my minus sine squared x into 1 minus cosine squared x, I get cosine 2x equals cosine squared x minus 1 plus cosine squared x, which is 2 cosine squared x minus 1. And that is exactly what I see. Now on this problem, the x is 22.5. So we're going to pass along, we're going to go from here to that is cosine of 2 times 22.5 degrees. So again, this is subtle. I see 2 cosine squared angle minus 1. 2 cosine squared angle minus 1. And that is equal to cosine 2 times that angle. So this is equal to cosine of 2 times that angle. This is cosine of 45 degrees, which is square root of 2 over 2. Next problem. Alright, in this one we have sine times cosine. And we have 22.5, which are not nice angles. It's nice when we double those. And we can double them, something to do with the double angle formulas. Now there's a double angle formula for sine, which makes nice use of this problem. Sine 2x equals 2 sine x cos x. Now, we just have sine cos. We don't have the 2. So I'm going to adjust our well-known formula to get a nice formula. Sine x cosine x equals sine 2x divided by 2. So in this problem, sine x cosine x, x equals 22.5. Let's write that down. X equals 22.5. And this value is going to end up on the other side as sine 2 times x over 2. This is sine of 45 degrees over 2. This is square root of 2 over 2 over 2, which is square root of 2 over 4. One thing you can do to make that over 4, clear fractions. This technique works really well in trigonometry. Square root of 2 over 4. It's a nice way to go. Alright, next problem. Alright, the left side, 2 minus tangent x over 2 plus tangent x. I don't really see any identity that I could use. Nothing's coming to mind. What I want to do is I want to check this one. Before I do a whole bunch of identity work, I want to see, I'm going to let x equal pi fourths, or let's do 45 degrees, so I don't have to write fractions. If this is an identity, if I plug in x into the left side, it should equal 1 always, including at 45 degrees. So 2 minus tangent 45 degrees divided by 2 plus tangent 45 degrees. Now you might see why I use 45 degrees, because tangent 45 is 1. 2 minus 1 over 2 plus 1. This is 1/3, not equal to 1. Not an identity. I'm glad that wasn't, because I didn't have much of a chance of doing that one first try. I was going to try multiplying by conjugates and things. And now you've got to be careful. Some people will try this kind of stuff. Oh, a tangent cancels, and then 2 over 2 is 1, and oh, no. Terms don't cancel. In fact, I probably shouldn't have even written that down, because then people might say, oh, I saw someone do this once. Alright, so this is an example of showing something is not an identity. All that it takes to prove something is not an identity is one example where it doesn't work. I use pi fourths because tangent evaluates to 1, which makes a very easy problem. And I use 45 degrees instead of pi fourths because I didn't want to keep writing fractions inside of fractions. And it all worked out that it didn't work. Now if I had gotten 1 equals 1 there, I might have just happened to pick 45 and it only works there. But chances are much higher than that this was an identity. And then I'd have to start playing around with algebra to see if I could get it to work out. It just didn't seem right though, so I thought I'd check. Saved me a lot of work. Alright, next problem. Alright, on this identity, on the left side we have cosecants and secants. I don't really like working with cosecants and secants because those identities are not ones I have memorized. I have the ones for sine and cosine memorized. I chose early on to memorize only a few and be able to work the rest out. And I never had to memorize the other ones. On the right side we have double angle formulas. So on this problem I'm actually going to work on the left side for a bit, then I'm going to work on the right side for a bit. Never working on both sides simultaneously. So I can't multiply both sides by 5 or anything like that. But I think that working on each side I'll find a common ground and that way I'll establish this identity. So on the left side I'm going to change secants and cosecants to sines and cosines. So I have 1 over sine. Let's go the right color. 1 over sine x minus 1 over cosine x divided by 1 over sine x plus 1 over cosine x. And this is a complex fraction. I'm going to multiply by whatever will cancel out both a sine x and a cosine x. So that would be a sine x and a cosine x here. That's sine x cosine x here. Sine x cosine x here. Sine x cosine x here. What this will do is allow me to clear the mini fraction inside this fraction, giving me cosine x minus sine x divided by cosine x plus sine x. This does not reduce anymore, and it doesn't look like an obvious thing to try anything else. I can think of one thing I would try if I had to, but let's start working on the right side now. Cosine double angle, that would be cosine squared x minus sine squared x. Denominator, double angle, 1 plus sine 2x is 2 sine x cosine x. We're trying to see if this is an identity. It might not be, in which case we could try x equals something that would be easy for sine and cosine, maybe 45 degrees again. But let's just keep assuming that this is going to work out. Now, looking at the left side and the right side. Now the numerator can factor, and it'll factor into cosine plus sine, cosine minus sine. I'm going to go there. I don't know about the denominator yet. Maybe this will help me. So this will be cosine x plus sine x times cosine x minus sine x. This is just difference of squares. We have like x squared minus y squared is x plus y, x minus y. Okay, and the denominator, I still don't necessarily see anything I want to try there. Alright, so we have 1 plus 2 sine x cosine x. Now the right side, I just do not see how that's going to work out to be the left side. So I'm actually going to continue working on the left side a little more. Sometimes you end up doing this. You try one side, you try the other side, you just keep trying to find a way that they connect. So taking a look at the left side and looking where the right side we want to end up with, I can multiply by the conjugate and get this up here. So if I multiply by cosine x plus sine x over cosine x plus sine x, what that gives me when I distribute in the top, first, outer, inner, last, like that. Let's see, first, outer, outer, there we go, inner, last. This will give me cosine squared x minus sine squared x. That gets the numerator to match up. That's better than we had before. Now the denominator, foiling the denominator out, we have the first cosine squared x. We have the outer plus cosine x sine x. We have the inner plus sine x cosine x. We have the last, plus sine squared x. Okay, again, the first is here, the outer is here, the inner here, and the last here. All right, quick, someone tell me what cosine squared plus sine squared is. The answer is 1. Good job. So the numerator, I'm not messing with, because that matches up with something on the right side, right here. Doesn't match up here. I don't think we're going to use that one after all, but that one does. The denominator, we have 1, looking good. Now let's take a look at these two. Cosine sine, sine cosine, these are like terms. It's like xy plus yx, or xy plus xy. It's 2xy. Cosine x sine x plus sine x cosine x is no other than plus 2 sine x cosine x. And although it wasn't my first attempt, let's see if I can do this. They're identical. I have the left side matching up with the right side. And what we have is identity. All right, hardest one yet, I think. Let's move on to the next one. All right, this one just looks wrong. Why I think it looks wrong is the left side is 2 sine x cosine x, and on the right side is just 2 sine x. So the 2 matches up, the sine matches up, the cosine doesn't match up. Now this will probably work as long as we keep cosine equal to 1, but let's think of a place where cosine is not equal to 1. How about where cosine equals 0? If I let x equal pi halves, let's watch what happens. 2 sine of pi halves cosine of pi halves equals 2 sine of pi halves. This is the question, does it or does it not? Cosine of pi halves is 0. So this whole thing is 0. The right side is 2 times 1 is 2. 0 equals 2. We have found a spot where this doesn't work. But an identity always works. Therefore, this is not an identity. Okay, moving on. By the way, you could have chosen any x value you wanted except for the values where cosine equals 1, because then it would look like it worked. But as long as it works, as long as it doesn't work any one spot, it's not an identity. Alright, decide whether the expression is or is not an identity. It doesn't look wrong, it doesn't look right, I can't really tell. I could try some x values to see, but I'm going to work with the identity a bit and see what happens. First off, recognize that tangent squared is just a shorthand for squaring tangent. And there is a nice identity for the half angle for tangent, including, there's two versions, sine x over 1 plus cosine x, and also 1 minus cosine x over sine x. Now the one I'm going to use is the sine x over 1 plus cosine x, because the denominator already looks right. So far so good. Let's see. Now squaring. The numerator just gives us sine squared x. The denominator gives us the whole thing, 1 plus cosine x squared. So we have to FOIL that one out. I have sine squared x over 1 plus 2 cosine x plus cosine squared x. I take it back. I'm not going to go there yet. Although it's something I can do, I remember, I just barely said it, that already matches up nicely, so I don't actually want to mess with it. That means that I probably want to mess with the numerator instead. So let's see. Where's my eraser? There's my eraser. Now I won't erase that at all. Interesting. Apparently I don't know this program well enough yet. Well, I'll just rewrite it. Okay, sine squared is 1 minus cosine squared x. The reason for that step is because there's no signs on the right side. So I had a sine squared, go to the cosine squared with my identity. The numerator is a difference of squares, so it's 1 plus cosine x times 1 minus cosine x. Over, now I'm going to write this one squared 2 times. Just makes it easier to see what to do in this case. And what to do is this, it's a factor of 1, giving us 1 minus cosine x over 1 plus cosine x, which is the right side. Identity. Great. Moving on. Alright, this one's sine squared x halves. If we go back to our regular sine x halves identity, there's a plus or minus and square root and 1 minus cosine x over 2. If I were to take this and square it, this is what we get. Sine squared x halves equals, now plus minus when you square it all goes plus. The square root when you square it goes plus. And we have this identity. Alright, so our left side, we now are working along. Let's see. I don't really necessarily know. Actually, I could do it a couple ways. Let's see, how do we want to do it? So taking a look, if we want to continue on this left side, which, notice the plus 1, we have a cosine x. We can fix that. We can divide by cosine x to make the 1. And what we'll get is, here we have 1 over cosine, that's a secant. Here we have 1, here we have 2 secant. So we have secant x minus 1 over 2 secant x. Now take a look at our identity. We're supposed to have a plus. We got a minus. So either this is not an identity and we need to just verify with like an x value, or I made a mistake. Let's take a look, make sure the identity is right. We have sine x halves is 1 minus cosine x. So the minus is there, minus is there, minus is there. This does not appear to be an identity. If you want to verify, we just need to find a value that works nicely when you divide it by 2 for sine. So let's go pi thirds, divided by 2 is pi sixths. That'll work nicely. So if I let x equal pi thirds, we plug it into the left side, we'll get sine, let me write it this way with the squared outside, sine pi thirds squared. The right side would be secant pi thirds minus 1 over 2 secant, sorry, plus 1. I am checking the original identity, so I want to make sure that this is the original identity. And that should be pi thirds, sorry. There. Alright, sine pi thirds is square root of 3 over 2 squared. That's 3/4. The right side, secant of pi thirds. Cosine of pi thirds is 1/2, so secant is 2. 2 plus 1 is 3. 2 times 2 is 3/4. So it appears to be an identity there. So now you get an idea of why identities can be difficult even for your instructors. This is good though. This means that there's something off somewhere. Now where is it? Let's see if we can spot it. Now if I were to plug in pi thirds to the right side here, it would be 2 minus 1 over 2 times 2, which is 1/4. Oh, geez. Well, this is crazy. I should probably re-record this one, but I want you to see what it's like to find your mistakes. So I believe in my work here, because I can see it, I've checked it over, that looks great, which means I should get 1/4 when I plug it into the left, but I didn't. So something's wrong here. And what it is I forgot to divide by 2. Divide by 2 makes that sine pi sixths, which makes that 1/2 squared, which makes that 1/4. Ah, man. Alright, so when we plug pi thirds in correctly into the left side, it gives us 1/4. When we plug pi thirds into the right side, it gives us 3/4. Not an identity. So although you can just plug a value in and check, you still have to plug the value in correctly and check. So this was a great example. Now I knew this wasn't an identity because I did the correct work to begin with. I went from sine squared, I used the half angle, squared it, made it look like the right side, and it wasn't the right side. So then it was just a matter of plugging something in, and I made a stupid mistake. I shouldn't say stupid, it was just a common mistake for mathematicians. You know, simple things. You know the basics, you can do all the hard stuff, and you forget to divide by 2. Alright, moving on. Alright, in this problem they give us something about an angle in what quadrant, so we know what to do there. We set up a triangle for that angle. Theta. Sine is 15/17. So, pulling out my calculator, 17 squared minus 15 squared. Try that up correctly. 64. Square root of that is 8. So we have an 8, 15, 17 right triangle, and everything's positive because to the right is positive and up is positive and hypotenuse is always positive. So now we have to work out what cosine 2 theta is. There are 3 different versions for cosine 2 theta, and it doesn't matter which one we use. I will use the one that I have memorized, which is cosine 2 theta equals cosine squared theta minus sine squared theta. Cosine squared theta is cosine theta squared. So these are both squareds. Cosine theta is adjacent over hypotenuse, 8/17. And sine was given as 15/17. Squared. We have 64 over and 17 squared, 289, minus 225 over 289, and 64 minus 225 is negative 161. 161 over 289. That's our answer. Now this is a negative answer. Sine theta is 15/17. It's in quadrant 1, but it's almost in quadrant 2. It's like 80 something degrees. If you double that, it's 160. It's in quadrant 2. And that's where cosine is negative. So that all matches up nicely. Verify the answer. Everything's looking great. Okay, next question. Alright, this is a similar question. Quadrant 3 angle. Let's create a quadrant 3 angle. Theta. Tangent is opposite over adjacent. Now I made that negative, I got to make this negative as well. Why are they negative? So here we have positive, but this is left 24 and down 7, opposite and adjacent. So the two negatives, when you do tangent, the two negatives make the final positive, but this is left and down. The hypotenuse, we have 7 squared plus 24 squared, and square root that looks like 25 is our answer. Quick calculation, 25. And that's always positive. It's a hypotenuse, always positive. Alright, so now we do sine 2 theta. Well, sine 2 theta is 2 sine theta cosine theta. That is 2 times sine theta would be opposite over hypotenuse, and cosine theta would be adjacent over hypotenuse. And 2 times 7 times 24, 336. So we get 2 negatives make a positive, 336 divided by 625. That's our answer. All right, next question. All right, these questions are getting very easy, three of them in a row. Quadrant 2. Notice all of my quadrants I'm drawing from the origin out. So that's quadrant 2, that would be quadrant 1, that would be quadrant 3, and that would be quadrant 4. And I'm drawing them in such a way that the angle is always the reference angle, which is measured off of the x-axis. Opposite 20, hypotenuse 29. 29 squared minus 20 squared, and square root that is 21. But that one's negative. Why is it negative? Because it's left. 20 is positive, up, right, and 29 is hypotenuse, also positive. So now we get into tangent double angle. Now if you've forgotten the tangent double angle formula, one thing you could do is go to sine double angle over cosine double angle. Or you could remember the tangent double angle formula. That's your choice. The tangent double angle is tangent 2 theta equals 2 tangent theta over 1 minus tangent squared theta. I believe there's other versions, but this one's a quick one to do. And what we'll get out of this is tangent is opposite over adjacent. It's 20 over negative 21 divided by 1 minus and squared 20 over negative 21. And now we simplify. 40 over negative 21 divided by 1 minus 400, and 21 squared is 441. Now to simplify this complex fraction, we could multiply by 21 everywhere. Two 21s. Why 2 21s? So we can clear out the 441. I should have multiplied by 441, but it all works out. You can always correct yourself in the middle of an operation if you need to. So we have negative 40 times 21. The denominator, we have 21 squared, and minus 400. So this is 40 times 21, negative 840, over, and 21 squared minus 400 is 41. And that's the end of that one. Next question. Alright, in this one, they give us cosine theta, so we can set up a triangle. Cosine's positive, and cosecant is greater than 0, so cosecant is positive, sine is positive, and cosine is positive. That all gives us quadrant 1. So we set up a nice quadrant 1 angle. Cosine is adjacent over hypotenuse, giving a square root of 15 for the opposite. Everything positive. Sine of alpha halves is plus or minus, but it's plus, because this angle, first quadrant, when you divide an angle by 2, when you divide a first quadrant angle by 2, let's imagine this. If that's really theta, then that's theta halves. It's still in quadrant 1. Sine is positive in quadrant 1. And the half angle sine, we have positive and square root of 1 minus cosine theta over 2. So we get square root 1 minus cosine theta is 1/4 over 2. Notice that we didn't even need the triangle. We did need to think about what quadrant though. But the 1/4 was already given the cosine, what we needed. But you never know what they're going to do, and these are so easy to set up, I always do. Alright, I'm going to multiply by 4 to clear the fraction. That fraction specific. So we have square root 4 minus 1 over 8. So we have the square root of 3 over 8. I'm going to multiply by one more 2, and this is to rationalize denominator, because that gives me square root of 6 over 16, and the square root of 16 reduces. Okay, next question. Okay, quadrant 4. Set up our quadrant 4 angle. Opposite over adjacent. Which one's negative? Well, hypotenuse is always positive, so that would have to be negative. Let's say 3, 4, 5 triangle. 4 is positive because it's right. 3 is negative because it's down. And hypotenuse is always positive. Now go to our sine theta over 2 equals plus minus square root 1 minus cosine theta over 2 in the square root. Now, which quadrant are we in? This will depend. Our answer is positive or negative. So if we were to pick some sample values like 330 or 300, and I don't need to do that second one. So 330 is a fourth quadrant angle. So what's half of that? It's 165, quadrant 2. You'll find that half angle, if you're in the fourth quadrant, half angle will be in the second quadrant. Same with the third quadrant angles, they half into second quadrant. And second quadrant angles half into the first quadrant. So our fourth quadrant angle, theta, halves into quadrant 2. So in quadrant 2, sine is positive. So we get plus. That does need to be worked out. Any of the formulas that have a plus minus in it, it's up to you to figure out what quadrant you're in. Now the half angle for tangent does not have a plus minus in it. At least many of the versions don't. There's one version that does. So for that one, the sine works itself out. But for the half angle for sine and cosine, they both have plus minus. It is up to you to determine what quadrant you are in, so you can figure out if you're plus or minus. This one's plus. 1 minus cosine is 4/5 divided by 2. And I'm going to multiply by 5 here, top and bottom, all the terms, to cancel that 5 out, giving me, and looks like I'm going to have to rationalize this one as well, square root 5 minus 4 over 10. That's square root 1 over 10. That's 1 over square root 10, which we can write as square root 10 over 10. Okay, that completes the review. This is the longest section, at least it seems like it's long. The next part of the review is chapter 4. And those are the trig equations. All right, thank you.